Alright guys, welcome back for this week's video. I'm going to be going over how to create custom operators within Airflow. First I want to go over how you can actually launch Airflow from Windows using WSL, the Windows subsystem for Linux. So here I've just went ahead and I created a very simple DAG utilizing a Python operator, which we will just log the word hello. We create our DAG here with a start date of the current time, utilizing datetime.datetime.now. And then we have our task here, which calls the Python operator, passes in the task ID, passes into the Python callable our function which we created called greet, and then the DAG equals DAG, which we defined here. Very simple stuff that we've seen before. But now, so in order to actually pass this into our Airflow directory, we first need to go ahead and run the file. So we're going to say python test.py, which is going to run it. And what it should do is it's going to go ahead and pass this into the DAG folder, which was in our Airflow directory. Here we're getting a warning, just it's a deprecation warning. So it's just telling me that it's attempting to link to the latest log directory. I actually have two Airflow directories on my system, and that's why it's kind of throwing this error. It's a little confused as to where it should go. But so now I want to run Ubuntu. So the file should already be in the DAG folder, but in order for this to actually work, you first need to run Airflow scheduler. And what that's going to do is it's going to go through, look at all of the various DAGs, and then assign the schedules to each one. We're also going to need to open up another Ubuntu shell, which will open up our Airflow web server by simply typing Airflow web server. So now, if you guys haven't gotten to this point and you haven't gotten Airflow installed on Windows, or if you don't use Windows at all, then obviously feel free to fast forward along in the video and we'll get to the more relevant stuff. I just wanted to address this issue that I ran into for several hours in case you yourself are trying to run locally on a Windows machine. So now that we've run that, we should see our Airflow server running on localhost 8080. Now we're getting some errors here, some broken DAGs. This was due to the lesson that I'm working on now. Unfortunately, I won't be able to actually run the DAG yet. Still working out some kinks as far as running this on Windows. Basically, it's unable to import stage to Redshift operator due to an error with CycopG2 not being found on my system. That is a whole nother can of worms that I'm going to have to address at some point, but this should basically give you guys the overall view of how you can create your own custom operators, which will help you along in your project. So this is going to be creating a stage to Redshift operator. It's going to be very similar to what you'll be working on in your projects. So the goal is going to be to grab some information, some data from S3, and then we're going to push it up to Redshift. So from airflow.hooks.postgres hook, we're going to import the Postgres hook. We're also going to utilize the base operator. And base operator is the key component into actually creating our custom tasks or operators. Then we're also going to import the airflow.utils.decorators, the apply defaults. So what that's going to allow is us to manipulate our class, which will be actually utilizing the base operator, and then we're going to be able to pass in our custom variables to it. So you can think of a decorator as we can work on other classes and actually add more parameters, more functionality to an already existing class without altering the original class itself. So hence the name decorator. It just kind of adds a little bit more decoration or functionality. You can think of it like that. We're also going to import dummy operator, DAG, daytime, and then this. Don't worry about the Scicop G2 here. So in order to access our AWS key, we can use the os.environ.get, and we'll say the AWS key, and AWS secret equals os.environment.get AWS secret. Okay, so now to the fun part. So here we're defining a Python class. The class is defined as such, where we say class, and then the convention is to name it in all capital letters. So we have our class stage to Redshift operator. And then here we're going to pass in a argument base operator. So what that's going to say is that the base operator is the parent class of the class that we're creating now. So what it will allow is us to gain full functionality of the base operator and then add our own custom components to it. So here we're just passing our template fields equals the S3 key. This is a tuple containing just one item. Here our UI color equals this right here. Okay, so now the decorator. Decorators are defined by passing in the @ symbol here and then the name of the decorator. So we're utilizing the apply defaults, which we had imported up here from the utils.decorators. So we say add apply defaults, and then we create this init function here. So the init function is basically the initializer for our class. All classes must have an init method within them in order to actually use the class or instantiate it. So we say define double underscore init, double underscore, and then this is where we pass in all of the various arguments or parameters that it will require. Very important here, when working with classes, you must always pass in self as the first argument. Next, we're just going to go ahead, we're going to pass in our Redshift connection ID, our table name, the S3 bucket, S3 key, delimiter. The headers, we're going to set equal to 1, quote character, file type, AWS credentials, which we're going to have as a dict, and then we're going to utilize the args and quargs, which will allow us to access the context variables. So next, we're going to use super stage to Redshift operator, self.init, and then the past that, the args and quargs. So what this is doing is we're now calling back the stage to Redshift operator, and we're going to inherit all of these variables which you defined up here. So the self, and then when doing this, we then have to define our variables by saying self.tablename equals table name, So all of the ones that we defined up here is we're going to have to rewrite them here by saying self.tablename equals tablename, self.redshift connection ID equals redshift connection ID, and so on for all of these various variables. So next, we define an execute method. Now we are still in the class stage2redshift operator. Just make note of that. So our execute method inherits from self, and then we're going to actually pass the context to it. So we can say self.loginfo, and here we're just going to pass in some log information, saying emptying stage table, and then a placeholder here, indicated by our parentheses. I'm sorry, our the magic method S here, and then with a format here and self.tablename. So we're going to pass in the table name that is actually it's working on at the moment. So here we define a variable called redshift, which is going to equal a Postgres hook, and then Postgres connection ID is going to equal the redshift connection ID which we pass to it. We must put the self here, otherwise we won't be able to access it because it was defined up here within the class. We're working right now in the scope of this execute method, so whenever we're using these variables which were defined up here, we must always pass in self before so that it knows which object or which class it's actually referring to. If you come from JavaScript, self is the Python equivalent of the this keyword. So it's basically just referring to the scope of where the variable exists. In this case, self is the class that we defined. So now that we have our redshift variable, we want to say redshift.run delete from, and we have a placeholder, and we're going to delete from self.tablename. Here we define our S3 path. We're just going to give it a placeholder here. So we have all the S3 buckets will have this URI, which is noted by the S3 : / and then we have a key, or I'm sorry, a bucket name, and then we're going to have the key, which will then pass in using Python formatting. Here we just have a print, which is going to print our S3 path. So now we want to copy some information from S3. So using SQL notation here, we're going to say our copy statement equals, we pass in the 3 quotation marks. So we're going to say copy placeholder from, so this is going to be the copy, the table name, from our S3 path, which we defined, which bucket and which key. Then we need to pass in our credentials, so access key ID, and then we pass that in, and then we must provide our secret access key, which we'll then pass in using Python formatting. So we're going to be working with various file types in this project. So we want to handle both cases when we're working with JSON data or CSV files. In order to do so, we'll utilize some if statements. So if self.fileType, which we defined up here, file type is equal to CSV. So we had defined it as having a default of CSV. So if you don't pass in anything to file type, it will automatically think that you're using a CSV file. So in that event, file statement equals delimiter, ignore header, and CSV quote as, and then we can pass in those various arguments. So in the event that we're going to be working with a JSON file, we say if.self.fileType equal JSON, file statement equals JSON, auto. What that will allow is the data to be copied in a JSON format automatically. So our full copy statement equals copy statement and file statement, which was this, and then the file statement, which handles the case for the CSV and the JSON, depending on what your needs are. Here we're just going to provide back a simple log statement, starting to copy data from S3. Now we need to utilize our Redshift operator and say redshift.run, full copy statement, self.log.info. We're going to say done if it works. So here I just wanted to create a test DAG. First we had to pass in the DAG ID, which I just called test. And of course, when it's initializing a DAG, you have to provide a start date, which I'm just going to go ahead and pass in the datetime now. So I'm utilizing a dummy operator here just to act as the starting operator. So this will be the very first task that is run in our directive acyclical graph. So it's just a dummy operator, pass the task ID, and which DAG it belongs to. So then to create our task to actually stage our events to Redshift, I'm going to call the stage to Redshift operator, which we defined, pass in our task ID, the DAG, and here now I can actually pass in the variables that I'm trying to access. So the table name that I'm trying to get to is our staging event. I pass in the Redshift connection ID, the S3 bucket, which I'm trying to access. And then I pass in the S3 key. The S3 key in this case is our log data /ds events.csv. I just set the delimiter equal to comma because it is a comma separated value file. I set headers equal to true or 1, quote char equals this, the quote character. Set the file type equal to CSV, and then finally pass in a dictionary containing our AWS credentials, which we had accessed up here using os.environment.get. Now I can just go ahead and define my dependencies. I first wanted to run my start operator, and then I wanted to pass it to the stage events to Redshift, which will be my second task in my DAG. Now, like I said, unfortunately, due to some technical difficulties, I am unable to actually run this right now. I've been running into all kinds of stuff. I think I've been booted off of AWS as well, getting some interesting errors saying that my account failed to retrieve account attributes. Certain console functions may be impaired. I am not quite sure why AWS has decided to give me the boot here, but hopefully I can get everything working here for next week's video. But I hope that this has been insightful for you when you're creating your custom operators for your project. The deadline is approaching very quickly, guys. This 4 months has kind of flown by, and we are in the very last quarter of the course. So I hope that we can go ahead and get these projects turned in, get you guys working on the capstone project so that you can go ahead and get your nano degree certificate. Once again, if you guys have any questions about any of the content, please feel free to reach out. No matter how small of a question it is, sometimes it just needs a second pair of eyes to look over your file. I've had a lot of different students reaching out And sometimes it's as simple as a spelling error, or in the case of tonight, forgetting to use that self keyword when accessing variables within a class. But no problem is off limits. I'm here to assist you, so please feel free to reach out. Schedule that one-on-one if you need it, and I want to make sure that you guys get your projects in and well underway on that capstone project. So anyways, guys, I'm going to tune out. I hope you had a great week, and we'll talk soon. Take care.